What you can see here looks a lot like Cucumber or any other DSL that you can use to create behavior-driven tests, but actually it isn't. Actually, this is only plain Kotlin code and JUnit. And in this video, I want to show you step by step how I created a test like this. My name is David Tanzer, and for almost 20 years now, I've been working as an independent software developer, consultant, trainer, and coach, and I'm helping teams and companies to write better software and to get better at writing software. A few weeks ago, I told you on this channel that I want to pause this channel to concentrate more on my German language channel that I called Quick Glance at Agile Engineering. But now I'm back because I wanted to show you this idea and how I came up with it. So let's get started, and to show you how I wrote this test and also to explain a little bit why I did that, I'm using the Gilded Rose Cutter. That's a refactoring exercise that's on the GitHub repo of Emily Page, and it's about an in a fantasy setting that sells certain items. Some of the items are magical, some are not, and the longer they are in stock, they degrade in quality or don't, and the requirements are not 100% clear, and the implementation is quite interesting. What you can see here, a lot of ifs and string comparisons, and generally not very nice code, and it's an interesting refactoring exercise. But today I will not refactor anything about the production code. I will only write some tests. I wrote a first test here, which says that sulfurous, which is a magical item, does not degrade in quality after 2 days in this case. So in the first part of the test, I set up the test. We often call this phase arrange. Then I execute one action in the system under test. In this case, it's waiting for 2 days. So calling update quality twice means waiting for 2 days. And then in the last part of the test, so the second part we often call act. And in the last part of the test, I verify that the system under test behaved correctly, and by calling JUnit assert, and we often call this phase of the test assert. When I rerun the test, we can see that everything is green for now. This test uses the system under test directly, so the test code directly uses the system under test to perform some actions and to verify the result. This is okay for unit tests or for tests on a very low level of abstraction, but in this case I want to write the tests from the perspective of the user using language from the domain, and I think we could write the tests on a slightly higher level of abstraction to make them more readable. And to do that, we can introduce a test automation layer. So the test uses the test automation layer, and the test automation layer uses the system under test. If we would want to write tests on an even higher level of abstraction, for example for longer running workflows, then we could even introduce another layer. So then the test would use the test automation layer, and the test automation layer could use an application driver layer which drives the system under test, but today I don't want to do this. Also, introducing the test automation layer does not necessarily have to be something complicated. It can be as easy as extracting a few private functions here in this test class, but today I want to go a little bit further, and now I want to show you how I'll do that. The first thing I want to do is I want to make sure that we separate the three phases arrange, act, and assert, and to make sure that setup code can only be called in the arrange phase, and so on. To do this, I want to write something like some object I'm calling spec dot given. This doesn't compile right now, but we can make it compile by creating a class here that I'm calling spec. This given function gets some kind of block, which is just a function, and it returns then a when. Okay, this looks a little bit like a builder pattern where we have functions that return an object where we can call more functions on. So for now, relatively easy. It still doesn't compile here because when is a keyword in Kotlin, but we can use backticks here to make sure Kotlin knows that we want to use it as a function. This also means that we have to use backticks here, and then it already compiles, almost, but I also want to use backticks here to be consistent, so that given when and then in this case all use backticks. Create the spec object and it should compile already. So the two tricks or Kotlin features I used so far is backtick functions, so that I can use when as a function name, even though it's a keyword in Kotlin. And the other Kotlin feature I've used are trailing closures, where when a closure or a block is the last argument of a function, we can write it after the function code. So instead of writing it inside the parentheses here, I can just skip the parentheses and write the closure afterwards. And because of those two features, this compiles. Now I can move the code in here. The setup code goes into given. So for now I've used an app that can be null and double exclamation marks in here. I will clean up this code later, but for now this is necessary. So the test compiles and it looks nice, and it probably even is green, but it's green for the wrong reason, because I'm not done implementing my test automation layer yet. I'm not calling any of those blocks that I'm passing here. So the test automation layer currently only sets up the structure for the compiler. So that's maybe another takeaway here. If you do larger changes, or if you create larger changes in your test automation layer, you should make sure that the tests can still fail. So I just broke the test. I added an impossible value here, and it's still green. So that's not what we want. And the fix in this case is pretty simple. I'll just have to call those blocks. Now the testing code works again, and I can fix the test. The next thing I want to do is I want to get rid of those double exclamation marks, and for that I want to simplify the setup code in the given here. So I actually want to write something like that, given. So that's the goal here. And here's how I'll do that. In the given, I can say here this block gets this pointer. I want to call this block on another object, and in this case I'm using an arranger here. And I'm currently creating all the classes in here. We should probably refactor them out into separate files later, but that's not really the goal of this video. So create the class arranger here. And here I can create this function items on sale. Fun. And when I use backticks here, I can also add spaces to function names. I want to encapsulate the item that's used by Gilded Rose in itself in a test item, so I can later do more interesting stuff with it. Like, for example, creating named classes for the items I want to use in tests, so I don't have to deal with all the parameters here in my tests. So here in the arranger, I want to create the Gilded Rose, but I also want to save the list of test items. And here I don't need test items, I need items, so I'll just map the test items to their item property. Now I've created the Gilded Rose in my arranger, and I can pass the Gilded Rose and the test items list on to the other steps. But we don't have the app here anymore. We have the Gilded Rose inside the test automation layer, but in able to call it, I'll have to use the same trick from before again. I will create two more classes where I can pass objects as this pointers to the other steps, and then I can use the test items and the Gilded Rose inside my closures here. And the cool thing now is Gilded Rose cannot be null anymore at this point, so I don't need the double exclamation marks here. Also here I don't have to query Gilded Rose for the items. I already have the test items. I should have them when I create them as a value here on the class. And now running the tests again, I should make them green again. So what we have so far is I have used trailing closures to pass blocks like that to functions that follow something like a builder pattern. This gives us the given, when, then structure that we know from Cucumber. Then I've used backtick functions to be able to use Kotlin keywords and also spaces in function names. I have extracted a test item class so I can create items for my tests more easily, like the sulfurous here. And I have passed different objects as this pointer to my code blocks, so I can use functions like this items on sale here, or also pass the created Gilded Rose to the next steps. And one of the advantages that I have already gained for that is that I cannot use setup code, for example, in the then step. So when I try to call items on sale here, it's just not there because it was only the object that contains this function was only passed to the given code block. Next, I want to use a language that is closer to the domain to express the fact here in when that 2 days have passed. And I can do this inside the actor here. I'm calling this function waiting for days because then I can write something like this here. And this already reads a little bit like English when waiting for days 2. Here I just have to call update quality for every day that was passed here. So for the test should still work. Now there's another Kotlin feature we can use here to make it even more readable, which is an infix function. An infix function gets always 2 parameters, and you can write it in between those parameters, and then you don't need the dot or the parentheses. And to be able to use this in an English sentence, I'm creating another object here that's actually just the this pointer, but I'm calling it items on sale. And I'm calling this have been in stock for. And then I can write here items on sale have been in stock for days. Okay, the autocomplete here in Fleet doesn't always work like I'm expecting it to. And I can write it like that. It's still not really English grammar, but we can fix that. I can create an extension function on integer. And I'm returning a time unit here. And create the class time unit. Now, since we're not waiting for days but for a time, I'm gonna remove the days here, and here I can write items have been in stock for 2 days. Test should still be green. Alright, what I did now is I have used an infix function to be able to write the English sentence like this: when items on sale, which is an object, then have been in stock for, which is the function call, and then a parameter without any dots and parentheses. So that was infix functions, and I used an extension function on integer to be able to write 2 dot days. And now when reads like an English sentence, and it uses language from the domain, language that hopefully our business users would also use when describing the system. So the last thing I want to clean up here is the then phase, and also try to reframe this then part in a way that contains less technical details and more language from the domain. To clean this then part up, I want to be able to write something like that. Items, the first one, so I think something like that will be more readable, and we can implement that with infix functions and by adding the assertion code to the test item and the value we expect also to the specialized test item Sulfurous. So test item gets the hasQuality function and Sulfurous gets an initial quality. Here in the test item, we have the gilded rose item, so we can query its quality, and we just pass the expected quality, which we will get from the initial quality of Sulfurous in this test case. And the initial quality goes into a companion object of Sulfurous, which is basically something like static fields in other programming languages. And I also use this value here to initialize the gilded rose item. The tests are still green, and in my opinion, they are. This one test is more readable now than the very technical test from before. As I've said, technical tests like the initial state have their value as unit tests, as tests that support us, but business-facing tests should probably be on a slightly higher level and use language from the business domain. And for that, I implemented a very small test automation layer using several Kotlin features. The first one was backtick functions or backtick identifiers, which allowed me to use Kotlin keywords like when and also spaces in function and variable names. The next thing I used are trailing closures, where when a closure or a block is the last argument of a function, then you can skip the parentheses, which allows me to write given and the block like that. Then I have passed a different this pointer to the closures, in this case the arranger here, to be able to add functions that can only be called in a certain phase, like items on sale can only be called in the arrange phase. Then I used infix functions to be able to write something like items on sale, then a function call, and then something without any dots or parentheses. I've used an extension method to be able to write 2 days here and get the time unit. And that's about it. That's what I wanted to show you. And that's it for today. If you have any questions or anything you want to tell me, anything I could have done better, please write it in the comments or contact me on Mastodon or Bluesky. And if you liked this video, please click the thumbs up button and share it on social media. Also, if you do speak German, also check out my German language channel about agile engineering and agile engineering practices. And all the links, also the link to the GitHub repo where you can find this code, are in the video description.